Hello everyone, my name is Prince Pandari. So in this video I'm going to show you how to perform the direct shear test. Before we start the test, let's learn about the direct shear test apparatus. Here you can see we have got a direct shear test box. The shear box has got mainly three parts: the upper half of the shear box, similarly the lower half of the shear box, and the top cap of the shear box. So it has also got few screws here. So these two screws with the black cap are called the lifting screws, which are used to lift the shear box with the sample and place into the machine. Whereas you can see these two screws are called the fixating bolts, which are used to fix the upper half of the shear box with the lower half of the shear box. So just fix them like this, and it will make sure that the upper half of the shear box is connected to the lower half of the shear box. Similarly, once we fill the sample here, the top cap will sit on the top like this, and then we'll place the shear box into the machine for the test. Before we place the sample, we should make sure that the surface of the shear box is clean and smooth, because while shearing, if any dust particle is present, then it may affect the shearing. So we have to make sure that these upper plate and the lower plate surface is smooth and clean. You can just use a foam here just to clean this cross-sectional surface of the shear box. Similarly, the bottom one as well, you can just clean this up using the foam. And to ensure the smooth shearing, we can use grease and apply along the cross-sectional surface of the shear box like this. So this ensures smooth shearing, as we know that the shearing will happen in a predetermined plane during the direct shear test. The size of the sample in this shear box will be of 100 centimeters square and 20 mm in height. If you notice here, the top cap and the bottom half of the shear box has got the porous stone surface here. So these porous stone will help to release the excess pore water pressure, if any present in the sample. Once we apply the grease into the shearing surface, we can fix the upper half and lower half of the shear box using the screws. Make sure that these screws are in place and fixed. So for this direct shear test, we will be using the sand. So I have got the sand of required mass to fill into the direct shear test box. As we know that this is sand, so it might have some dust particles while placing into the box, so we can use the dust mask to be safe from the dust particles. To place the sand into the shear box uniformly, we can use a funnel. So in this way we can uniformly distribute the sand mass inside the shear box, as you can see here. We can perform the direct shear test for the loose sand and the dense sand. In case of loose sand, we don't perform any compaction, whereas for the dense sand, we have to perform some compaction. For the compaction, we can just use this compaction device and the hammer. So we can just place this on the top of the sample and hit it with the hammer uniformly. For the loose sand and the dense sand, all the process are same. Only difference is that for the dense sand we have to perform the compaction. But for now we will just use the loose sand and perform the direct shear test. Alright, so here you can see that I have already placed the sand into the shear box. So here we have got a special device, we can call it a scraper. We can just hold this scraper into the shear box and just drag it along to make sure that the sand is uniformly distributed. So as you can see here, it will scrape the sand surface and make it smooth. So do it on both sides. So it looks perfect. So now it is ready. We can use this top cap on the top of the shear box. So just hold it with both hands and just release it together. Now it is ready to be placed into the direct shear test machine. We can just lift this whole box using these two lifting screws and place into the shear box machine. Before we place the direct shear test box with sample into the machine, I would like to give you a brief info about the machine itself. So here we have got an advanced shear test machine. If we have a closer look, you can see it has got the keypad here, which can be used to control the machine and run the test. So here you can see the force in kilonewton and the displacement in millimeters. So we can see the applied load and the displacement of the sample here in the screen here. So either we can use this keypad to run this test, or we can just use the software in the computer here to run the direct shear test. If we have a closer look, you can see it has got a S-shaped load cell which has the capacity of 5 kilonewton. So this will measure the axial load. Similarly, you can see here it has got a sensor here, or you can just simply call it LVDT, which will measure the vertical displacement. Likewise, at the back we have got the another LVDT here, which will measure the shear displacement or the horizontal displacement. So as this box will move or shear, so this sensor will get the horizontal displacement value. Once we place the direct shear box with the sample into the machine, we have to make sure that the load cell LVDTs are in proper position and fixed properly. Once we finish that, we have got one more important task to do, which is placing this screw. So this screw will be placed at the back of the machine. Here you can see there is a hole here. So this screw will be placed into this hole, as you can see I'm doing now. So this screw has been placed into its position. The main purpose of this screw is that it will establish the contact between the machine and the shear box. So the shear force will be applied through this screw and the sample will be sheared. As soon as we place the shear box into the machine, the first thing we have to do is we have to take out these lifting screws out of the machine. Otherwise these screws will obstruct the shearing, so we can just take these lifting screws out. We only use these screws when we have to place the sample, the shear box with the sample into the machine, or once the test is finished, we can use these screws to take these shear box out. So once we open the software, the next step is to connect the software with the machine. If we have a closer look here, as you can see, there are a couple of options here to connect the software with the machine. We just have to press connect and it will activate the connection. So once we press connect, we have to press this on button. It will turn on the connection between the software and machine. So once we perform that, once we connect the software with the machine, we just have to select the role. So in the role option, we have to select the service role. In the service role, we will have much more options than other roles. So we have here service role, developer role, and lab assistant role. So service role has more options, so we will select the service role option. So if we have a closer look again, here we can check status is on. That means the software is connected with the machine. Once we select the service role option, we have a couple of options available here in the software. The first one is station, definitions, test procedure, manual controls, logging, and console. The first thing we have to select is manual controls. Once we select manual controls option, we will have this window open. So here, if you can see at the top, there is a channel option. In the channel option, we will select settlement channel. Once we select settlement channel, we will have some values here. The main task we have to do before the test is that we have to make sure that the loading RAM of the load cell touches the top cap of the direct shear test box. To ensure that there is much less gap between the loading RAM and the test box, we will select all commands option here. Once we press all commands option, we will have this new window box open. In the command, we will select ramp. In the secondary channel, we already have settlement. So here we can see we can put some values here to minimize the gap. In order to move the ramp upward, we will provide the value here as +1. So once we provide the value of destination as 1 mm for the speed of 0.8333 mm per second, we can execute this command. Once we execute this command, you can see the machine is running and the ramp gap has been minimized much more than before. Since we can see the gap has been minimized much more, now we can set these values to 0. So we can do that by pressing set tear. We will select set tear. Now you can see the value has been 0. So the measurement will start from 0 now. The next step is to get the graphs. Now we have to set the graphs. So for the graphs, we just select the console option here. Just press console. Once we press that, we will find this option here, click here option. So just click this drop down button and you will see the diagram option here. So select diagram. So we can select as many graphs we can. So I will select 3 for now. So here, if you go to this range option, click this one, you can see it doesn't show any value for X or Y. Once we run the test, we will be able to select what we should put in the X-axis and the Y-axis. So once we get these 3 diagrams option here, we can run the test, and as the test will run, it will show the value of X and Y axis, and also we can choose whatever we want in the X and Y axis values. So now let's start the test. To start the test, we can select this start or continue test button here. Just select that one. Once we select the start or continue test button, it will open this window box here where we have to check a couple of parameters before the test. In the general parameters section, we can see here initial sample height 20 mm, sample surface area 100 centimeters square. In the shear parameters, automatic start of shear test, we have to check it yes. Speed of horizontal loading is 1 mm per minute, that's okay. Maximum shear displacement is 15 mm, that means that is the maximum displacement it will go, and the test will stop there. Similarly, effective surface calculation, we just make it yes. Maximum vertical force to consolidate. So here we know that we need at least 2 more circles to draw the failure envelope line, the tangent line. So for the first test, we will just apply the load of 25 kPa, that is 250 Newton. One of the disadvantages of this direct shear test is that we can't apply multiple stress at once, whereas for the triaxial test we can apply multiple stress at once. So that is the benefit of triaxial test over the direct shear test. So we have to do one by one for the direct shear test, which is much more time consuming, but that's okay. For this test, let's start with the 25 kPa, that is 250 Newton. So once we set everything, we just press OK, and then we'll save the file somewhere in the desktop or anywhere you want, and just save the file, and then we will continue the test. So here you can see establishing the sample contact. So the machine is running the test first. So first it will establish the contact with the sample here. That means the RAM will establish the closer contact with the shear box. This is the notification area. So here it will display all the notifications, like what is happening, what to do when. So everything will be displayed here, like when to remove the fixating bolts. So everything will be notified here by the software itself. It's very easy to operate this software. So you can see here it is establishing the contact. Now you can see here the loading RAM is getting closer to the direct shear test box. So now here in the notification area it says sample contact established. That means the loading RAM has established contact with the shear box. Second notification, it says consolidation stage. So we just press continue, it will start the consolidation stage. It's very simple. We just follow the notification from the software. As I told before, when the test is running, we can select the graph axis values. So here you can see we have 3 diagrams. So let's select the first one, and then once you select the first diagram, just select modify option, which is like wrench icon. So you just click this one. You will see this diagram properties dialog box. So here you can see it says create file. consolidation or shear test. So we know that for the direct shear test there are two stages. One is the consolidation stage and another is the shear test stage. So let's create the graph for the consolidation stage here. So select the consolidation stage here, and in the x-axis we can just select time. In the y-axis just select settlement. So one graph has been added. You can see here, we can see the graph. Similarly, select the second diagram here, and then again select the modify option, which is the wrench icon, and again let's create the another graph for the consolidation. In the x-axis time should be fine. In the y, let's select the force, add graphs. You can see another graph here, and in the third diagram again let's modify it, and the third we can select for the shear test, and in the x-axis we can put shear displacement, and in the y-axis we can select the shear force. So you can see here three graphs has been added. So here we can see the consolidation stage has started. You can see here in the machine itself the value of force is increasing now, the vertical force is increasing. Similarly, the displacement value is also increasing. So force value is going up, and here also you can see the graph. As the force value is increasing, the displacement is also increasing. Very simple to understand. So here we can see we have got a new notification from the software. It says please remove fixed setting bolts. With the confirmation of this message, the shear test will start immediately. So the next step for us is to remove these two fixed setting bolts. If you have noticed here, we have got two minor screws here. One is this one and this one. So before the direct shear test, once we remove the fixed setting bolts, we have to rotate these screws in such a way that they will create the gap between the upper half and lower half of the shear box. Doing so, it will create a gap for the shearing of the sample. Once we remove the fixed setting bolts, we can press continue here so that the shear test will start. So now here you can see it says shear test running, and also we can see the graph is coming now in the shear test graph, settlement versus force. You can see the graph is coming now. The shear force is increasing, displacement is also increasing. You can see three graphs here together. So here we can see the test has been finished, and we have got three graphs from the test, two graphs for the consolidation stage and one graph for the shear test. As you can see here, settlement versus the time graph for the consolidation stage, it says that it shows us that as the settlement increased, as the force increased, after some time the settlement got constant value. Similarly, for the consolidation stage, here you can see the graph for force versus the time. Force got increased, and after some time, similarly, it got the constant value here. For the third graph, for the shear test, shear force versus displacement graph, we can see here, as the shear force increased, the displacement also increased. After the failure, the shear force decreased and got constant after some point of time. So here we can see all the three graphs, very straightforward and clear. So this is how we perform the direct shear test and get the results in the graph. We can add more graphs according to our need. It is very easy and straightforward process. So now I would like to show you how to extract the data to the Excel file. So here you can see we have got the results here that we have extracted from the software. So now we just copy it and paste it into the Excel file. So here I have copied and saved into the Excel file. So now we can draw our own graph as well. We can see here there is time, force, shear force, settlement, shear displacement. Similarly, we have effective vertical stress, effective tangential stress. So according to our need, we can just use this Excel file and draw our own graph. So this is how we perform the direct shear test using the direct shear test machine and computer software. Once we finish the test, we have to make sure that we have to take out the sample from the machine and clean the direct shear test box carefully. Thank you everyone for watching this video. I hope that this video will be very useful for you guys to understand the direct shear test process. If you have any questions and doubts, please feel free to consult your supervisor, or you can contact the lab techs here in Melbourne campus. You can contact myself, Prince Pandari, through an email, or Rag here in Melbourne campus Civil Lab. You can contact myself through an email. My email is p.bhandari@cqu.edu.au, or you can contact Rag through his email, which is r.vadhupadhyaya@cqu.edu.au. Once again, thank you everyone. Stay safe, take care.